Okay, so in this example, we're not finding any kind of surface area or lateral area or anything like that. All they want us to do is practice finding the slant height or the actual height. So if you take a look at part A here, we see that what we have, and it's kind of hidden behind that little line there, but all that we see that we have is the actual height here is given to be 8 meters. And then we also know that what's called a lateral edge, right, is 12 meters. And some other things we know, we talked about how we are only in this class doing regular pyramids. We're only doing pyramids that have all the sides on the base congruent. So this is a regular polygon, essentially a square on the base of this pyramid. And so that means these are all 12 all the way around the bottom of that pyramid. Okay, so we know the height. In this case, they're asking us to find the slant height. So what is our slant height? Because it's not given to us. That's the one we don't know. And so what we can do is let's draw in our very own slant height there because it wasn't drawn for us. So that's our L. And then the 8, remember, is referring to the red segment. And so the other thing we can do here is we can draw in our very own line that goes from that red line. It starts at the red line and it goes to the bottom of the green slant height. It goes all the way out to the edge of the square. And what I have just done on purpose so that I can find that slant height is create a green right triangle. So what we know about that green right triangle is that the left side is 8. We're trying to solve for the hypotenuse, the slant height L, and we also know if this is a square and half all the way across the square here is 12, then we know that halfway across to that altitude there is going to be half of 12 or 6. So now we have enough information. We can solve for the green triangle. So here, I'm going to redraw that green triangle out here to the side just to make it abundantly clear what's going on. We have the red segment, which is 8. We have the green segment, which is slant height. And then we have the base of this, which we said was 6. And so we know we could use one of our right triangle strategies to solve for L. We could use the Pythagorean theorem. Some of you might even recognize that this is one of our triples. So let's see, this is 6 squared plus 8 squared equals L squared. And so this is actually a 3, 4, 5. We know 3, oh, that's not 3, Miss Benton. 4, that's the 4. This is 3, and so this would be the 5. And so what we mean by that, the 3, 4, 5, is we mean that 3 times 2 is 6, 4 times 2 is 8, so 5 times 2 would be our L. Or if you're not comfortable doing the multiple of the triples like that, you can do the good old Pythagorean theorem. Either way, you get your L to be 10. So that's your answer on that one. So on this next one, let's take a look at this one. What we have on this one is the slant height. We said we know it's the slant height because it's on the side of the pyramid. It's slanty, right? What we don't have this time is the one going down the middle, right? The actual height. And so that's going from the top vertex down to the exact middle of that square in the bottom. So let's do this. Let's pause the video and I want you to try to find the height, to find the blue segment in the middle. What is its length? Okay, so I hope you just paused this video and I hope what your next step was to draw in the segment connecting the height to the slant height. And you conveniently made a right triangle by doing that. We also know if it's 10 all the way across that square, then halfway across the middle would only be 5. And so we're going to do the Pythagorean theorem again. This time we know our L, we know our C, our hypotenuse is 12. So this is 5 squared plus h squared equals 12 squared. This is not the 5, 12, 13 triple. I know that because remember your hypotenuse is always the longest side. It's the biggest side. It's the one, and so it would have to be 13 in the C spot. So this is 25 plus h squared equals 144. So we're going to subtract 25 from both sides. And so h squared equals 119, square root it, and our height equals the square root of 119, which is 10.9 approximately for the actual height.